Welcome to Maths with EJD. And in this series, I've been talking about basic calculus, and I've made two videos on differentiation. This is the third video on differentiation, which will be like the seventh or so on the whole of basic calculus. Okay, so today in this video, my focus is turned to product and quotient rules. That's what this video will be about. And as you can see, so starting with product rule, right? A product is simply when you multiply two things, right? A product is a result of multiplication. So in this case, you have your function y now as a product of two other functions, u and v. So, and u is a function of x and v is also a function of x. You know, what we have always known is that y is equal to f of x. Now, that f is now expressed as the product of u of x and v of x. And that is why we call it product rule. And the simple idea for product rule is this, that you take the first function u of x multiplied by the derivative of the second function. So you have u of x dv of x dx plus, then you take the second one, v of x du of x dx. So if you have a product of three functions, you do the same idea, except that now you take them in two. So you have u and v together multiplied by dw dx. Then here we have y equals u of x, v of x, w of x. So you take u of x, v of x multiplied by dw of x dx plus u of x, w of x, dv of x dx plus v of x, w of x, du of x dx. And you go like that. So if you have more than three also, so if you have four, you take three and you multiply by the derivative of each one in turn like that. So that is what the product rule is about. But then how did this come about? How did this come about? So you see, everything always comes from the first principle. So how did we come about the fact that we should, if you have uv, you should have u dv dx plus v du dx. So let's see how that came from first principle that we saw in the first I think that must have been in the first video for differentiation. That's video 5 altogether overall for calculus. So from first principle, we have that y equals u of x times v of x, which you can simply say is uv to make things a bit tidier. So let's just say uv, and then you know that a little change in x will cause a corresponding change in y. But in this case, instead of x directly, to now be u and v. So a change in v, in u and v, which will make uv become u plus du times v plus dv, will also lead to y plus dy, or delta y if you like. So that's basically the idea there. So the next thing is you're expanding everything up. So you have y plus delta y, then u times v, uv, u times dv, u dv, du times v, v du, du times du, that's du dv. That way. And then the next thing is, since you need delta y, delta x at the end of the day, which will lead you to dy dx, so you can transfer y here. So now that y is there, and you remember that the original y was uv, so you have this expression. So you have uv plus udv and all that minus uv. So you see this uv will cancel this uv, and that is what will take you to this next step. So uv cancels out, and then you have this. So at this point now you can divide through by delta x, as we usually do in first principle. So you have delta y, delta x, and that will now be u delta v delta x plus v delta u delta x plus delta u delta v delta x. Now I hope you know, like I keep saying, delta u delta v, all those delta anything, they are changes that are usually very small changes. So it's more like 0.1 is small and another 0.1 is small. If you multiply the two together, you have something even smaller. That's 0.01. Now imagine that the change is like 0.01 and the other change is 0.01. So by the time you multiply those two, you have something way smaller still, right? So I'm saying that so that we can understand what is going to happen to delta u, delta v later, because there are little changes being multiplied together. So it will even result to even far little change, Okay, so you have divided through by delta x. So the next thing is to take the y dx, which means you're taking the limit of delta y delta x as delta x approaches 0. So that means limit as delta x goes to 0 for this whole expression. And this is like limit of three sums. So the limit of a sum is the sum of the limits, like we know from the rule of limits that we saw yesterday. So you find the limit of this, and this. So you have, of course, u is out of it. So you have u limit, because u does not contain delta anything. So you have u limit as delta x goes to 0 of delta v delta x, v limit as delta x goes to 0 for delta u delta x, and limit as delta x goes to 0 for delta u delta v divided by delta x. Now, just like I told you now, so this will just be nothing serious. So you have u delta v delta x, and here you have v. This is v delta u delta x. And because this is a small chain, this is a small chain, by the time they multiply themselves out, it becomes even smaller. So this whole expression goes to 0. And that's why you have 0 here. And at the end of the day, you end up having the expression u dv dx plus v du dx. And that is how, so whenever you see that rule, it didn't just come from outer space. It came from first principle that you've already been introduced to. So that is the idea of product rule. So now let's go on. Okay, this is slide 20. Let's go to slide 21, where we can play with some examples. Okay. So this is first example. You have to differentiate y equals x squared plus x minus 1 into 3x squared plus 5x plus 1. So, of course, you have this function like your u of x, and this is like your v of x. So that's a proper product of functions, right? So you can say, let u be x squared plus x minus 1, and automatically the u dx will be differentiating this. That'll be 2x plus 1. And then you also say, let v be 3x squared plus 5x plus 1. So dv dx will be 6x plus 5. This is 6x if you differentiate, and this is 5 when you differentiate. This is 0 because it's constant. So such that you can now say dy dx is u dv dx plus v du dx. So this is u, and this is dv dx. This is v, and this is du dx, like this. So the next thing to do is to expand, multiply things out. So you have x squared times 6x, that's 6x cubed. X squared times 5, that's 5x squared. And then you have x times 6x, that's 6x squared. X times 5, 5x. Minus 1 times 6x, minus 6x. Minus 1 times 5, that's minus 5. And then the next thing is 3x squared plus 2x, that is 6x cubed. 3x squared plus 1, that's 3x squared. 5x times 2x, 10x squared. 5x times 1, 5x. Then you have 1 times 2x, 2x. 1 times 1, you have this 1. So things are getting tidier. Then you collect them together, and let's see what we get. So for the things that have x cubed now, 6x cubed plus 6x cubed, that is 12x cubed. Then you have 5x squared, 6x squared, that's 11x squared. What else? Plus 3, that's 14x squared plus 10, that is 24x squared. And then we go to the x's. 5x minus 6x is minus x. Then minus x plus 5x is 4x. 4x plus 2x, that is 6x. And lastly, we go for the constants. So that's minus 5 plus 1, that's minus 4. And that's it. And then you see that you can factorize 2. So you have 2 out into 6x cubed plus 12x squared plus 3x minus 2. So to differentiate this, this is what you get, right? That's what you get. And then, the normal thing a layman would have done was to expand this whole thing, and you end up getting the same result for sure, but then maybe it's not as smart as what you have here. So that's our first example. So now things get a bit more complicated here, because now this is normally x squared plus 1 is a function multiplied by this as a function, but then x squared plus 1 is now has a square root. That means you are more or less doing a function of a function, mixed with product, and everything is just like that. So see what you have here. You have u is square root of x squared plus 1 equals x squared plus 1 raised to power half. And that's what that expression is for easy differentiation. Now, one thing you should know about function of a function normally is this. So anytime you have function of a function, you don't even have to go through all the stress. So you already know this is x squared plus 1 raised to power half. So all you just need to do, 3 things. Bring down the power, that's half. All right. That's the first step you do. Bring down the power, you get this. Differentiate inside the bracket, you get 2x. That's when you differentiate x squared, you get 2x. Then the original expression you had, the whole thing, write it out. But then the power that was there will be reduced by 1. So half minus 1 is minus half. So that's the smart way of doing function of a function. So again, bring down the power, differentiate inside the bracket, and keep the original thing, but then the power reduced by 1. And that's where you have done your function of a function without having to do du dx times du dx times, no, du dy dx, right? So you don't have to do du dx times dx du or something like dx dy also. Yep. Normally that is dy dx is equal to the y du. Yeah, dy du times du dx. So you do without doing this. So you can just go straight, bring down the power, differentiate inside, keep the original thing, but reduce the power by 1, and then you're good to go. So all we just have next is to tidy this whole expression up. 2 cancels 2, as you can see, and this is x squared plus 1 raised to minus half. And of course, you have this x, and don't forget about it. So you have x over square root of x squared plus 1. So we have our du dx sorted that way, which is actually a function of a function. And then v is easy peasy. So v is x cubed minus 3x plus 5. Then the v dx will simply be 3x squared minus 3. And 3 is common, so you have 3 into x squared minus 1. And of course, x squared minus 1 is difference of two squares. So that's x minus 1, x plus 1. I've talked about it a couple of times along the line. So all you just need to do is tidy everything up. So dy dx is u dv dx plus v du dx. So what is u now? U is this guy, and you have it here. dv dx is this, and that's what you have here. Plus v is x cubed plus 3x minus 3x plus 5. That's it. And then du dx, as you can see, this is du dx like this, and that's why we brought it here. This is it, right? But we tidied it up to be this. And then the next thing you just need to do is to begin to tidy things up better. So you have all this put together. So you have 3 into x minus 1, x plus 1 into square root of x squared plus 1. And then for this other part now, you have x into x cubed minus 3x plus 5 all over root x squared plus 1. And then the next thing we are doing is to take the LCM, like put this over 1. The LCM will be this. So, and then that's why you have this here. And because you have that, so 1 in square root of x squared plus 1, that means square root of x squared plus 1 multiplied by the square root of x squared plus 1 that was there before. And that's why you have 3 into x minus 1, x plus 1. Then square root of x squared plus 1 raised to power 2. So it means you have not heard the last of this. And then you have x into x cubed minus 3x plus 5 right here. So we still go on to clarify this. So we are still on it. So you see now you have, because you had square root of x squared plus 1 squared, the square cancels the root. That's why you have x squared plus 1 left here. And then for the other one, you have x into x cubed like that. So that's why you have x raised to power 4 minus 3x squared plus 5x all over that LCM. All right. So we are still tidy. So the rest is just to tidy things up. So you have now that this is x minus 1, x plus 1 is the same thing as x squared minus 1. You have this 3 outside, and then this is x squared plus 1. And then you have x raised to power 4 minus 3x squared plus 5x. Now you see again, this is looking like another difference of two squares, except that now x squared minus 1, x squared plus 1 is the same thing as x raised to power 4 minus 1. And then this is x raised to power 4 normal. Just put that back here. And then you have square roots of x squared plus 1 usual down, and then you have this now and this tidied. Then the next thing is we want to see how we can tidy things up further. 3x raised to power 4, 3 times minus 1, that's 3, and then we have x raised to power 4 minus 3x squared plus 5x all over square root of x squared plus 1. Then you just tidy up 3x raised to power 4 plus x raised to power 4. That's 4x raised to power 4. Then minus 3x squared is here. Then you have plus 5x, then the minus 3 all over x squared plus 1. And that's the final thing you get. So this is the result of that thing, as complicated as it looks. Now, it looks really, you have to really be careful not to make any mistakes, not to, a minus or plus thing can just mess things up for you. So you have to be careful while you handle something like this. Just know the rule and keep a clear focus and just go carefully. So, and with that, that's the end of quotient rule, and then we move on to that's the end of product rule. Now we come to quotient rule. a quotient is simply the result of division. A product is the result of multiplication, while a quotient is the product of division. So when you want to differentiate two functions that are dividing themselves, something like a rational function, how do you go about it? That's what quotient rule deals with. Now, given that y equals a function over another function, u of x over v of x, of course, v of x must be not equal to 0 to avoid the whole function being undefined. Then the rule here is v du dx minus u dv dx all over v squared. And that is what your dy dx is for quotient rule. Again, this didn't just come about out of the blues. It came from first principle. And I'll always serve you as it is from the very source. So from first principle now, see what you have. You have y is u of x over v of x, and that is equal to u over v. So now again, we go ahead to talk about, first principle is that a change in the independent variables will lead to a change in the dependent variable. And again, so in this case now, instead of just having y equals f of x, you now have y equals u of x and v of x. So it means the changes are occurring in u and v, and that's leading to change in y. So you have y equals u over v, right? So that means as u becomes u plus du and v becomes u plus dv, y becomes y plus delta y, or dy, as you may want to call that. And then ultimately you need dy dx. So y has to be transferred to the other side. So you have delta y or dy equals u plus du over v plus dv minus y. And then don't forget that the original y was u over v, so you put it back here. And then we have some arrangement to do. So the LCM of v plus dv and v is v into v plus dv. So v plus dv into this is v. So v times u plus du is v into u plus du. V into this, v cancels out. So you have v plus dv multiplied by u. All right. So u comes into v plus dv. And then the next thing is we expand, right? So v times u is uv. V times du is v du. Then minus u times v again, uv. Then u times dv is minus u dv. And of course, down here you have v squared plus v delta v, like this. So that, of course, that's not the end of it. We keep going. This is slide 25. So it means that it continues in slide 26. Slide 26. Okay, yeah, this is slide 26 now. Don't forget where we were at. So here we are dividing through by delta x, right? So, and that means you have delta y delta x equals v du v delta u minus u delta v all over v squared plus v delta v multiplied by 1 over delta x. And now see how that works. Now when you're dividing like this, it's just one delta x. It's not like you're dividing each term through. So it's only dividing the up or down, right? Or it's multiplying the down and dividing the up. That's one way to look at it. So if you come here now, you have delta y delta x equals v delta u delta x minus u delta v delta x, that way, all over v squared plus v delta v. All right. And then you have delta dy dx now is when you take the limit of all that. So you have limit of delta y delta x as delta x tends to 0, and that is limit as delta x goes to 0 of v delta u delta x minus u delta v delta x over v squared plus delta v. So let's see what goes. And then this is, you have a difference at the top, and the limit of a difference is the difference of the limits. So that means you have v limit of delta u delta x as delta x goes to 0 minus u limit of delta v delta x as delta x goes to 0. Then you also take the limit of the v squared down there, and you also take the limit of delta v. So by the time you're done, you know that wherever delta v is remaining, right, as we used to know in when alpha is tending in limit, right, as far as you have delta v down, so that thing is going to affect whatever expression you have. So, and you have this will just firm up and become v du dx here, and this becomes u dv dx, and this has no delta x. It has no delta x, so it just remains v squared. And then this one that has still has v something. So most of it is approximated to 0, and then you have 0 down there, right? And then by the time you tidy things up, you end up having the formula, the formula for quotient rule, which is v du dx minus u dv dx all over v squared. All right. So let's take some examples. Look at the simple one. You want to find the derivative of this rational function y equals x squared plus x minus 1 all over 3x squared plus 5x plus 1. So easy. let u be x squared plus x minus 1, so that du dx will be equal to 2x plus 1. You know, when you differentiate x squared plus x minus 1, you get 2x plus 1. Then v is 3x squared plus 5x plus 1. So dv dx is just 6x plus 5. So now dy dx would just be v du dx minus u dv dx all over v squared. We have proven this, so you know where that came from. So v is this, you have it there. Du dx is this, you have it there. Then u is this, you have it here. And dv dx is this, you have it right there. So next, you just tidy things up, tidy things up, tidy things up. You have 3x squared times 2x, that's 6x cubed. 3x squared times 2x, that's 3 times 1 rather. You know, 3x squared times 6 times 2x, that's 6x cubed. 3x squared times 1, that's 3x squared rather. 5x times 2x, that's 10x squared. 5x times 1, that's 5x. 1 times 2x, 2x. 1 times 1, 1. So that's taken care of. And then you come to the other side, but you have to be careful. There's a minus here, so you have to be sure everything still remains in brackets. So you don't just open it up without having applied the minus. That's very important. So as you expand this and this, you have x squared times 6x put in bracket because of the minus. That's critical. So x squared times 6x, you have 6x cubed. X squared times 5x, that's 5x squared. X times 6x, 6x squared. X times 5, 5x. Minus 1 times 6x, minus 6x. Minus 1 times 5, that's minus 5. Like that. And then we have not heard the last of this. We have to open up this bracket now and apply the signs. So some of the signs are definitely going to change as you apply minus. So we go to this. We go to that now. Okay. So some tidying up being done on this side, first of all. Some tidying up happening there first before we open the bracket up. So you have dy dx now is okay, let's go back to that. You have 6x cubed, that's the only 6x cubed you have there. And then you have 13x squared for this. That's 3x squared plus 10x squared, and then you have 7x. So that's why you have 6x cubed plus 13x squared plus 7x plus 1 minus all this. And then we go next to open up the bracket. So minus 6x squared, minus times plus, that's minus. Minus times minus, that's plus. Minus times minus, again, that's plus. So again, it's tidier now. Then you can do everything. So you have 6x cubed canceling out 6x cubed, and that's all gone. 13x squared minus 11x squared is 2x squared. 7x plus x is 8x. 1 plus 5 is 6. And then you have this thing down here. So the final, you can factorize 2 from here. So you have 2 into x squared plus 4x plus 3. And this is your result for that particular quotient. Okay, so and then we have another example, something a bit more complicated. So it's like function of a function over function of a function, and then it's quotient rule, and everything is just coming together. So with this kind of thing, you have to be very smart in an exam situation, because you can get bogged down trying to say let u be x squared plus 1 and all that. But I've told you what to do. If you have function of a function like this, you have a very smart way of doing it. So if y is square root of x squared plus 1 over square root of x squared minus 1, find dy dx. So for, y is this already. So let u be square root of x squared plus 1. I know that's simply x squared plus 1 raised to power half, like I told you. So that means dy dx, du dx would be bring down the power, that's half, differentiate inside, that's 2x, keep the original thing, but reduce the power by 1, that's x squared plus 1 and raised to power minus half. And then, like we saw before, this cancels out, and you have x divided by root x squared plus 1. And same for v. V is square root of x squared minus 1. That's x squared minus 1 raised per half. Again, bring down the power, that's half. Differentiate inside, that's 2x. The original thing retain and reduce the power by 1. That's x squared minus 1 raised per minus half. And again, you have x over square root of x squared minus 1, like that. So that you can continue. Now that you have done all the things you need to do, you can continue to tidy things up. You have dy dx equals v du dx minus u dv dx all over v squared. So this is v, this is du dx minus u dv dx all over v squared, and then let's see, the LCM here, as you can see, is square root of x squared plus 1. So you have square root of x squared plus 1. 1 in square root of x squared plus 1 is square root of x squared plus 1. Oh, okay. It's multiplying, not LCM yet. We are multiplying. I was wondering. So we are just multiplying. So x times square root of x squared minus 1 all over square root of x squared plus 1. So it's not LCM, it's multiplication, not addition or subtraction yet. So we have that. Then on this part, we have x into square root of x squared plus 1 all over square root of x squared minus 1 all over, square root of x squared minus 1 squared. 2 we cancel roots. So we have just x squared minus 1 left down there. Okay, so then you can now take LCM. So the LCM is square root of x squared plus 1 into square root of x squared minus 1, which you have here. And then this goes in this. You need to cancel this out. So you have x squared minus 1 multiplied by the x squared minus 1 up. That's why you have x into square root of x squared minus 1 all squared minus x into this goes again. So it's so this cancels this again. So you have this plus. So you have this squared again. So of course, you know that the roots are going to cancel out because of the power. So 2 roots will go, 2 roots will go, as we'll see in the next slide. That's slide 31. Okay, yeah, this is it here. So because of the square root and power, right? The power 2 cancels the square root. So you have x into x squared minus 1, x into x squared plus 1, all over this LCM, and then this x squared minus 1. So next you can tidy things up. You have x times x squared, x cubed, x times 1 minus x times x squared minus x cubed minus x times minus time plus 1, that's minus x. So again, you see that this cancels this. So you have minus x minus a, that's minus 2x. And then, of course, you see this one, if you tidy it up, it's like you have a over b over c. So it's like you have a over b divided by c, that's times 1 over c. So you see that that's like a times a over b times c. That's why you see this x minus 1, x squared minus 1 multiplying this LCM right here. Okay. Just like I said, this is a over b divided by c. That's like a over b times 1 over c. So that's why you basically have what you had at the top. Let me leave this the way it is. Then, so you have this canceling this, right? And you have minus x minus x, that's minus 2x all over all this. So, I mean, just to tidy things up, you have this is x squared minus 1 raised to power half, right? So because of this one now, raised to power half times 1, that's raised to power 3 over 2. So that's square root of x squared minus 1 raised to power 3. And then you have this here. So that's the result of that complicated looking stuff like that. Okay, so that's another example of quotient rule. Then a very good example would be bringing it into trig, right? For instance, you want to find the y dx for y equals tan x. How do you differentiate tan x? We already know if you differentiate sin x, you get cos x. We have done that using first principle. I've also given you an exercise to try cos x. Of course, from that, you're going to get minus sin x. So the next thing is to find tan x. How do you find tan x? Tan x, of course, you can use first principle, but a nice way to also still do this will be quotient rule, because we know that tan x is the same thing as sin x over cos x. That's more or less like quotient rule. So you can now say let u be sin x, so that when you du dx, when you differentiate sin x, you get cos x. We have seen that. Then when you differentiate cos x, you get minus sin x, which you will see from if you do the exercise from the first differentiation part. And then having done this, you have dy dx now equals v. V is cos x du dx is cos x again, minus u is sine x, then dv dx is minus sine x, as you can see. So, and then we have cos x times cos x, that's cos squared x, minus sine x times minus sine x, that's plus sine squared x. And we know that, I mean, before now, you already know that cos squared x plus sine squared x is equals 1. Then, of course, we have cos x squared, which is v squared. V is cos x all squared. So you have cos x all squared. So you have cos squared x plus sine squared x divided by cos squared x. Cos squared x plus sine squared x is 1. Then all over cos squared x. And we know that the reciprocal of cos is sec. So 1 over cos squared x is sec squared x. So when you differentiate an x, you get sec squared x. That's what this is telling you. So with this, we have come to the end of product rule and quotient rule. But as usual, I have exercise for you to play with to test your strength. So, and here they come. So, so you need find the y dx using product rule for these three. And then, of course, this will require you to use quotient rule. You can see cut X waiting for you there. You can use quotient rule right there. The last one is about implicit function, which I'm going to take in the next video. All right. So thank you so much for listening. Make sure you subscribe so you can always get notified when I release a new video. Of course, that means you would have pressed the bell button to see you then.